All right, guys, today we're going to work on lesson 6.3. And today we're going to look at two new lines we can create inside a triangle, which are medians and altitudes. Medians we're going to do more work with than altitudes. The altitudes really we're just going to learn to identify. The medians, though, we're going to do a little bit more with, like I said. All right, so we got definitions for both. They both have their applications. We're going to do more with medians. All right, so today's openers is this. Let's say that you were asked to hang these chimes from the ceiling from this piece of triangular wood. All right. You are able to attach, you can attach one cord to it. So where would you place the cord? Let's say that I take this triangle and I put it in a coordinate plane that looks like this. Where would I put the cord so that when I hang this from the ceiling, this piece of triangular wood is parallel to the ground? It's hanging perfectly level. Well, there is a point that's not that hard to find inside this triangle that is the center of balance. It's the central point of balance. It's perfectly uh, um, balanced, I guess, in that if I was to put my finger right on that point and lift it up in the air, this thing would balance just perfectly on my fingers, the center of gravity, if you will. All right. So today we're going to work on being able to find that point. And like I said, it's not too tough to do. To find that point, we have to use medians. And a median is defined as a line segment that has one endpoint on a vertex of a triangle and the other endpoint at the midpoint of the side opposite. Okay. If you put all three medians in a triangle, in other words, connect the vertex, all three vertices, I should say, to the midpoint of the side opposite, they will all meet in the triangle at a point called the centroid. And that centroid is the center of gravity for that triangle. Okay. It's the balance point. All right. We have a centroid theorem, and we're going to use this a lot. Okay. Once we find the centroid, then if I look at those three different medians in the triangle, they are all in a 2-to-1 ratio. In other words, from the vertex to the centroid is 2/3 of the distance all the way across, or the segments are in a 2-to-1 ratio. And I'll show you exactly what I mean by that in a second. Um, Again, I mentioned this, the centroid is the balancing point. It's the center of gravity for a triangle. And if I want to find the centroid, if they give me a triangle in a coordinate plane, like I did in our opener, there's a very easy way to find that point that is a balance point, and that's this process. We're going to take the average of the x coordinates for the points that represent the vertices. So you add the three together, divide by 3, that's the average. Take the average of the y coordinates, add those three together, divide by 3. That resulting ordered pair is the balance point. It's the centroid. All right. And I'm going to show you that right now. Let's go back to this question. So you're tasked with putting one string, attaching one string to this triangle so that when you hang it from the ceiling, it hangs balanced. Okay. To do that, we can use one of two methods. One method, if I'm in a coordinate plane, is to do what I just showed you. To find the centroid, I'm going to take the average of the x coordinates that represent the vertices and the average of the y coordinates. So I'm going to go 1 plus 11 plus 7. 1 plus 11 plus 7, divide that answer by 3. And then I'm going to go for the y's, 1 plus 5 plus 10. I'm going to add that by 3. So I'm going to get 19 over 3 and 16 over 3. So that's 6 1/3, 5 1/3. Okay. So if I go on my x-axis to 6 and roughly 1/3, and then go up here 5 1/3 and come over and meet, that centroid is about right here. Okay. That's one way to do it. Another way to do it, and if you had a piece of wood laying on a table in front of you and you were asked to do this, then what you would want to do is measure this distance from this point to this point and mark halfway down, mark the midpoint. Well, I can do it on a coordinate plane by the averages. 1 plus 7 is 8, divided by 2 is 4. So the x coordinate is 4. 1 plus 10 divided by 2 is 5.5. So this midpoint is at 4, 5.5. So that's the midpoint for this side. And then on this side, 7 plus 11 is 18, divided by 2 is 9. 10 plus 5 is 15, divided by 2 is 7.5. That's the coordinate for this midpoint. 1 plus 11 is 12 divided by 2 is 6. 1 plus 5 is 6 divided by 2 is 3. That's the midpoint here. So I'm going to find all the midpoints. Now I did it on a coordinate plane. You could just measure the length, mark halfway, measure the length, mark halfway, measure the length, mark halfway. And then connect each vertex to its midpoint opposite. So vertex to midpoint, vertex to midpoint, vertex to midpoint. Those three are going to meet at a single point. That point is the centroid. There's your balancing point. Mark that on your board. Lift your board up, put your finger right there and hold it in the air, and that board will balance perfectly on your finger, parallel to the ground. This is the center of gravity for that triangle. All right. And notice that I did this on Desmos and marked that point, and it came out right at 6.33 repeating, which is 6 1/3, 5.33 repeating, which is 5 1/3. Okay. Now, why I have you here, let me show you real quick what I was talking about with the centroids. Okay, if I go from this vertex to the centroid and then look at the centroid to the median here, this one is twice as long as this one, 2-to-1 ratio. This vertex to the centroid to this midpoint, 2-to-1. Same here, vertex to centroid, centroid to midpoint, 2-to-1 ratio. So let me explain. If this was, let's say, 20 units long, here to here, then centroid to midpoint would be 10. If this was 12 units from this midpoint to the centroid, if that was 12, then from here to here would be 6. So it's always 2-to-1 in terms of their length. All right. Okay, so that's a look at the centroid and the uses thereof. Now let's look at homework questions. All right, so they're going to give you this drawing, and guys, you're going to have to make these drawings tonight, and you're going to have to label everything in them. So get prepared for that. All right, so here we go. M is the centroid. So they're labeling M as the centroid. Now that tells me a lot. Number one, I know the centroid was created by connecting the vertex to the midpoint opposite. So I know J is the midpoint of DE. I know K is the midpoint of EF. I know L is the midpoint of DF because that's how we create this centroid, vertex to midpoint opposite. We also know that E to M is twice as long as M to L. D to M is twice as long as M to K. F to M is twice as long as M to J. And those are the ones they're going to have you work with. All right, now they give us some information. Let's plug it in. M to L is 12. So they're telling us M to L is 12. Right now, and I'm going to go through the process, but right now you know E to M is 24 because E to M is twice as long as M to L. Bam, 24. We'll get that in a minute. M to J, they tell me is 11. If M to J is 11, M to F is 22 because this line is twice as long as this line. That's how centroid works. Now, D to K is kind of a tough one. D to K, the full length across here is 27. Guys, if we're in a 2-to-1 ratio, we've really divided the line into 3 parts. 2 parts go here, 1 part goes there. So when I take this 27, I'm going to actually divide it by 3 to figure out DM and MK. And I'm going to show you that right now because the first question is find DM. So how far is it from D to M? All right. So what you can do mentally is say, all right, if I take 27 divided by 3, I get 9. Okay. DM is 2 times 9. And MK is 1 times 9 because it's a 2-to-1 ratio. What I did is took 2/3 of it. Why? Well, I'm going to divide DK by 3. That's the denominator. And then I'm going to multiply that by 2 because DM is twice as long as the other one. So if I do 2/3 times 27, I get 18. Remember here, 27 divided by 3 is 9. 2 times 9, 18. So I know this distance is 18. That makes MK 9. Okay, I'm just going to fill the whole thing out. Okay, how about EM? E to M. Well, E to M is twice as long as M to L. So E to M, we already knew this, was 24. How about F to J? F, so they want the full distance across here. So make sure you do that. F to J. Well, what we know is F to M is twice as long as J to M. So I know F to M is 22. That makes F to J 11 plus 22, which is 33. Okay. Pretty simple to do, guys. You're going to have to make this drawing for me tonight to go with all your answers and fill out the interior here. Okay. Let's do another one. So again, they tell me that I have a centroid. G is the centroid. If I know G is the centroid, then I know D is the midpoint on this side, E is the midpoint on this side, F is the midpoint on this side. And we know then C to G is twice as long as G to D, A to G is twice as long as G to E, B to G is twice as long as G to F. I'm going to use that information, right? Here we go. They tell me B to F, this full distance is 30. So take 30 divided by 3, you get 10. B to G is 20, 2 times 10. G to F is 1 times 10, 10, right? We'll do that in a minute. A to G, this is 20. You know G to E right now is 10. And they tell us C to G is 10. That means G to D is half of that because this one's half of this one. That's 5. Now, we're going to fill all that now because they're going to ask me these questions. The first one is, what's A to E? A to E. So they want the full length of this. Well, A to G is 20. We know G to E is 10. So we know A to E is 30. Okay. How about G to D? G to D. Well, we know that's half as long as this one, right? If this is 10, this one's got to be 5. Okay. Half of CG. And then finally GF. Okay. So where are we at here? GF. Oh, this is the one, right? We said G to F is the shorter of the two. The full length is 30. So a third of 30, right, is 10. So G to F is 10. B to G is 2 times that, which is 20. All right, so it's that 2 to 1 ratio in here that we're going to use to solve these. You're going to have to draw all these, right? Okay, the last thing I want to talk about are altitudes of triangles. And guys, primarily what we need to do here is identify an altitude. All right, and it has its own definition. An altitude is a segment that extends from a vertex to the opposite side and is perpendicular to that side. Every triangle has 3 altitudes in it. Okay, where they meet is called the orthocenter. We're not going to do anything with orthocenter. Okay, but what we're going to do is be able to identify an altitude. These 3 lines drawn in here are altitudes. So I connect vertex B to side AC, which is opposite, on a 90. That's an altitude. I connect A to BC on a 90. This one is an altitude. And I connect C to its opposite side on a 90. That's an altitude. So that's an altitude. It connects a vertex to the opposite side on a 90. The next set of questions are, we really got to study here. Okay. Now, I want to read this to you because it's important. Classify the segment in each part below. Only use the information given. You cannot assume that measures are equal unless they are given markings to indicate that. Okay, so select all that describe the segment CD here. Okay, I know what you're going to want to do. You're going to want to assume that DB and DA are the same length. They are not, or they would have gave us markings. Okay, so let's talk quick this through. So is CD the perpendicular bisector of AB? Is it perpendicular to AB? Yes. Does it bisect AB? They don't tell us that. So we don't know that it's the perpendicular bisector. Mark that one out. All right. Is DC an angle bisector of C? Are they showing me that these 2 angles are congruent? We can't assume it. So are they clearly showing me that? No. So that one's out. Is it a median of the triangle? Am I connecting the vertex to the midpoint of the opposite side? No, they don't show me that these 2 are the same length. I don't know that D is clearly the midpoint. That one's out. Is it an altitude? Do I connect the vertex to the opposite side and am perpendicular to it? Yes, this one's an altitude. That's it. That's all you know for sure. Next one. Now I'm looking at GI. Is it a perpendicular bisector? Well, it's not perpendicular. They don't show me that. They got to show it to me. So that's out. Is it an angle bisector? Yes. I'm extending from G and I'm cutting it into 2 equal angles. Yes. Is it a median? Am I connecting the vertex to the midpoint of the side opposite? It might be, but they're not giving me markings. So no, we don't know it for sure. Is it an altitude? Am I connecting this vertex to the opposite side on a 90? No, they're not showing it to me. So the only one we know for sure is that it's an angle bisector based on the drawing. So you got to go through each one of those and answer the question carefully. How about MN here? Is it a perpendicular bisector? Well, is it perpendicular to JK and bisect JK? Yep. Is it an angle bisector? Well, we're not even extending from vertex L to bisect its angle, so no. Is it a median? Am I connecting the L to the midpoint? No. Is it an altitude? Am I connecting the vertex L to the opposite side on a 90? No. The only one that one is a perpendicular bisector. And then finally, this one, look at your drawing here. Is it a perpendicular bisector? Well, it does bisect GH, but do they show me it's perpendicular? They do not. Cannot assume it. That one's out. Is it an angle bisector for F? Are they showing me that it's been dividing into two congruent angles? No, that's out. Is it a median? Am I connecting the vertex to the midpoint of the side opposite? Yep. Is it an altitude? Am I connecting the vertex to the opposite side on a 90? Nope, not showing it to me. So this one is just a median. So guys, you got to go through that process for all of those. All right. So you're getting two types of questions tonight. You're going to be given a shape that is a centroid and asked to find different missing segment measures. Guys, you have to draw those out. That's going to be work you have to show and turn in. And then you're going to be given some, like we just did, identifying a segment within a triangle as to what it could be. And you have to have an eye for detail there, and you cannot assume anything. You can't assume right angles. You can't assume bisecting. You can't assume anything. You have to be shown it. Okay? All right. I'll let you have at it.